Start the lecture. So this is the eighth lecture of the beginners class in binary brains. So today's topic is prefix sums, difference arrays, and circular arrays. And I am Mayank Tayal, BTech third year CSC student, and I will be taking your today's lecture. So uh, these three are the some techniques that we use in programming as a sum pre-computations. Prefix sums, difference arrays, circular arrays. These are some pre-computation techniques. Firstly, when we write a program, when it may not be that we are initially given all the tasks that we have to do on our data. So we mostly require to have some pre-computations on our data to uh, to be able to perform the later computations at a lower time complexity. So we mostly use these data structures to do that in a much more lower time complexity. So the goals of today's lecture is 2D prefix sums, difference arrays, some examples, and circular arrays. So as from the last lecture, prefix arrays uh, prefix array is an array consisting of the sum of the prefixes of our original array. So we have an array A from 0 to n minus 1, and prefix of I will define the sum of all the elements from A0 to AI. So we have a array prefix which stores the prefix sum. So if we want to find the sum of elements in some range, we can easily do that by separate. Like if we want to find the sum of elements from L to R, we can easily take that sum till R minus sum of till L minus 1. So this will give our sum of the range. So now uh, addition to that is 2D prefix sums. So 2D prefix sum is similar to 1D prefix sum but extended to two dimensions. So like like we did in the 1D prefix sums, we are given originally given an array, and we take a prefix to find and store the sum of that to and using it we can find the sum of elements in any range. This is similar to that, but in this we are given a 2D array. So what we will do it, instead of some line, we will take a rectangle and we will store the sum for that for each uh, I comma j. So what we'll be doing is, so suppose this is our 2D matrix. So for every I comma j, we'll store the sum of all the elements from that line the rectangle of 0 comma 0 to I comma j. So if we want to compute the sum of so the suppose what we will evaluate this node. So this will store all the sum of all the elements from 0 comma 0 to here. So the value at 1 comma 2, so this is this cell, it will be the sum of all elements in this rectangle, so it will be 30. So like this we will be storing the values in our prefix array. So let's compute what will be the how will calculate the prefix of I comma j. So uh, let us say we want to calculate the value at 2 comma 2. So this 2 comma 2, so how will we calculate it? So firstly we can take a rectangle. So firstly, to compute the value at in all these so to calculate the value of all the sum of all the elements in this rectangle, we can that is the value of at this node. We can do what is we can take this rectangle and this rectangle to find the sum, and after subtract what is this is common in that, so we can subtract uh, the common rectangle to and that will give the sum of elements in this rectangle. So what we are doing is, to find the sum of all elements in this rectangle, we are firstly finding the sum of these elements, and later uh, another thing, we are finding the sum of these elements. So this will give us the sum of all the elements in this, but there is something we are adding two times, so we'll need to subtract this also. So for calculating the prefix sum of I comma j, we are uh, get we require prefix of I minus 1 comma j, I comma j minus 1, and we are subtracting this. So it will be prefix of I comma j is equal to prefix of I minus 1 comma j plus prefix of I comma j minus 1 minus prefix of I minus 1 comma j minus 1. So this is what we have. And yeah, we need to add that element also. So this is how we are calculating our prefix sum for 2D arrays. So uh, now if we want to calculate uh, sum of some subarray in this 2D prefix sum, so how will we do that? So like before, in one array we are given a range, we find in this we are given a rectangle. Suppose this is the rectangle, we need to find the sum for. So for that, what we will do is we will first take the bigger subarray and just subtract these two positions. Subtract these remaining elements from this. So uh, for this, we need to subtract this and this. Uh, but this part will be subtracted twice, so we will add it again. So if we want to find, suppose this is A comma B and this is C comma D. So if we want to find the sum of this subrectangle, so it will be, firstly we will take sum of C comma D. So this will give us the sum of all the complete rectangle. So after this, we need to subtract these two smaller rectangles. So for that, we will do is what uh, to find the sum of here it will be stored the sum of the rectangles elements of this rectangle. So it will be sum of A minus 1 comma D. And likewise, for this rectangle, here the sum will be stored. So we need to subtract sum of sum of C comma B minus 1. So now we subtracted both these rectangles, but this part is subtracted twice. So we need to add it. We need to add it to get the result. So it will be sum of A minus 1 comma B minus 1. So this is what we had. So now, what is the time complexity to calculate the prefix sums? Firstly, for this calculate the prefix sums, uh, we need to, for calculating the prefix sums, we need to store the value at every node in the array. So the array size is of n, and for uh, every node we are requiring just one operation, like this is the single operation we are requiring, so this can be done it of one. So the total time complexity of the prefix sum comes out to be of n into m. And likewise, and now if we want to find the sum of submatrix in the array, so uh, we are also doing that in of one. So uh, the time complexity to calculate the uh, sum of some subarray in submatrix in an 2D matrix is of 1 using the 2D prefix arrays. But suppose if we didn't use 2D prefix arrays, so what would be the original time complexity? Uh, then we'll need to add the elements single one by one. So this will come out to be of n. For the worst case, it will come out to be of n into m, because we need to add we need to add all the elements of this 2D array. So in the worst case, the time complexity of, if we don't use 2D prefix arrays, then the time complexity to calculate the sum of the subarray will be of n into m. And suppose we have q queries, so it will be q into n into m. But now we are doing it in of one time, so it will be of q. So we are optimizing it from q into n into m to of q, which is very good optimization, and this helps us a lot in our later problems. So the next topic is the difference series. Now we are given the difference series phase. You are given q queries of the form l comma r and k K meaning you add the value of k to the L comma R. That array is initially filled with zeros. What is the final array? So in this initially we are given some array like 0 comma 0, and now we are given some queries like uh, we are given some queries in like L, some range of some of range in which we need to add some constant element. So like we are given 2 comma 6. So this is the range, and we are said to add 2 for to all these elements. So what will be like? And in next query we are said to add 3 to 4 comma 7. So what is it? 0 1 2 3 4. By adding 3 we will get it 5 5 5, and here it will be 3. So we have this type of queries, and after that we need to find the element at each index. So what will be the time complexity of this operation? So if like suppose we are given for some range L comma R, we need to add k at in single query. We are given some range L comma R, and we need to add some constant element to those all the to all the elements in this index. So it will be the complexity of this operation will be of n, because the range can be the complete array, and will be requiring of n computations to do all that. So for single query, our time velocity comes up to be of n. Now if we have q queries, then it will become of n into q, which is not desired. So we'll try to optimize it. So now suppose we are asked now, for that we will use difference arrays. So now take it as initially this array is 0 comma 0. So according to our computations, but we have computations 2 comma again. So these were our queries L comma j L comma R comma k. So in the difference arrays, what we do is if we want to perform this type of query, then instead of adding adding k at all the indexes, we will add k at position L. We will just do two steps instead of adding L comma R to all these indexes, all the elements in the L comma R. We will do is what we will do is we will add k at L com uh, Lth index, and will subtract k from R index, kth index. So what actually is happening in difference arrays? In difference array, uh, let's define it as different instead of a, let's denote it as difference. So what are difference array stories? Difference of I stories stores the value of a of I minus a of I minus 1. So this stores the sum of the elements, difference of the consecutive elements. The ith If this is the ith element, then difference of I will store the difference of these two elements. So this was like this. So now if we suppose we are given some array like this, and we want to find the ith element, then what we will need to do is we'll just need to take the prefix sum. So let's see it how it is coming. So difference of 1 is what? Firstly, difference of 0, as it's a base case, it comes out to be of 0 only, because there is no left element of it. So now difference of 1 is what? A of 1 minus a of 0. So now from this, what is a of 1? A of 1 is basically difference of 0 plus difference of 1. And now we also calculate a of 2. A of 2 will be, so difference of 2 will be a of 2 minus a of 1. So from this, a of 2 comes out to be difference of 0 plus difference of 1 plus difference of 2. Sorry. So a of I is basically this sum of prefix sum of the subarray from 0 to I till I. So this is how difference array works. So now what we have are prefix queries. We had queries like to update L comma R, to update to add K to all the elements to L comma R. So suppose we are given range 2 comma 6 and we need to add 2 to all these elements. So what we will do is, instead of adding all by using different arrays, we don't require to add K to all the elements in the range. We just add it to the first element, and as it is a difference array, so the effect of it will be continue to all the elements to the right. So like this is the difference array. So now if we just add 2 to this element, then the effect of it will be continue to all the elements. So like let's see how it's happening. So let's calculate the original array by how it got changed if we change the element at the second index to 2. So we just need to take the prefix sum, so it will be 0 2 2. So we can see that we just added 2 at index 2, but the effect of it continued to the whole array. So this is how the prefix sum works, difference array works. So so now problem was to add 2 comma 6 2 to all the elements in 2 comma 6, but it got added to all the elements. So we need to subtract the elements from the remaining from the elements from 7 to the all the right. So we just wanted to add 2 to this range, but it got added to all these elements. So we need to subtract 2 from these elements. Okay. Okay. So okay. So I will start with difference array again. Okay. So what was the difference array? Uh, in basically difference arrays, we are storing a of difference of I is storing uh, a of I minus a of I minus 1. So like initially, suppose we are given some array 2 3 4 and 5. So now we want to make the difference array from it. So for the base case, it will be the same. It will be the same. Sorry. So now for the remaining elements, what will we do is for difference of I, it will be the difference of these consecutive elements. So uh, for the first index, we'll just need to take the difference of these two elements. So it will be 3 minus 2. So one. Yeah, I will do that later. So I'm starting again from the difference. So for the difference array, how we calculate is difference for the ith index. It is just the difference of ith index and I minus first index. So uh, like for the base case, for the zeroth index, it is same as a of 0. Now for the first index, we'll take the difference of a of 1 minus a of 0. So it is 3 minus 2. Now for the second index, it will be a of 2 minus a of 1. So it will be 4 minus 3, like 1. And again it will be 5 minus 4, so 1. Now it may have a positive negative values also, even if all the elements are positive. So now for that, suppose we have 2 and 1 after this. So for the fifth index, what will be the value? The value of it will be 2 minus 5, which is minus 3. So you can see that we are having a negative value in the difference array, yet all the elements in the array A were positive. Okay, so this is how the difference array is made. And we use difference arrays to solve our such queries. So what kind of queries we solve by using difference array? Suppose uh, we are initially given an array with all the elements as 0, and now we are said to we are given queries like update all the elements in range, add k to all the elements in the range from L to R. So what will be our basic approach if we don't use any difference array or anything? So suppose we are this is our starting element. So and now we have two queries. Add uh, two two elements in 2 comma 5 and add 3 two elements in 3 comma 6. So how will we do it? So we'll just iterate the array and add to the elements, add 2 to all the elements in 2 comma 5. So how will we do it? So it will be 0 2 2 2 2 and 0 and 0. So this will have a result after the first query, and after the second query. Yeah, yeah, I'm taking it as the uh, I was taking it. Okay, sorry. I was taking it as the first index, so it doesn't matter. You can take it as zero index or one index. So okay, now I'm taking it as a zero index array. So it is 2 to 5. Now in the second query, it says to add 3 to all the elements in 3 comma 6. So now it will be 0 0 2 5 5 5 5, and the last will be 3. So this is how we need to we will do we will do this. So for each query, what is the time we are taking? So it will be of n, because the uh, for L comma L, we need to iterate all the elements in the range, and it will be maximum it can be of n at max, because that's the size of the array. So for single query, the time we are taking is of n. And now if we have q queries like this, so our time complexity will reach to of n into q. And now as programmers, our task is to optimize this. So how we'll do it? Uh, our solution to that is difference arrays. So uh, we read difference arrays, the difference of these two consecutive elements. So how will we use that approach in our problem? So again, we start with array with all the elements as 0. Now if we are given if we have to perform these two queries again, so how would it work in the difference arrays? So for this type of query, like we need to add k to all the elements from L to R. We need to sorry, I got by mistake denied. You can say him to add join using IIT Indore ID, if anyone knows him. So Continuing it, uh, suppose we had it yeah, we have operation to add k to all the elements in L to R. So in the difference arrays, what we need to do is to add k to elements in L comma R. In difference arrays, we need to do two things. We'll add k to k at position L, and second is subtract k at position R plus 1. So in these two operations, we can perform a query. So we will see how it is working. So let's uh, what was our queries? Add 2 to 2 comma 5. So what was our queries? Add 2 to at position 2 comma 5. So what we will do is, instead of in difference arrays, we don't require to add to all these positions. We uh, we will just add 2 at the starting position and subtract it from the later position, from the from 1 plus the last element in the range. So it will be like this. So now how it is working? So as this was our difference array, this is new difference array is a of I comma a of minus 1. So suppose we have some difference array, difference of 0, div 1, div 2, div 3, and now according to our formula, 0 div 0 is a of 0, and difference of 1 is a of 1 minus a of 0, and difference of 2 is a of 2 minus a of 1. This is just equation. This I am writing through just only this, like we knew before. This is how we make the difference array. So I am just doing that, writing this equation, and using this we will find the original array A. So this is just equation. These are just equations how, of the difference arrays. So now if we want to find the original array A from this, so how will we do that? So A of 0 from this, what will be the value of A of 0? Yeah. So as like difference of 1 will be, if you solve this, it will come out to be difference of 0 plus difference of 1, diff of 1. So as like all for all, it will be come out to be prefix sum of the elements from 0, prefix sum of the element at I. So what I have a question? A of I is basically prefix sum of difference array. So this is how we are getting it. So back to our query, back to our question. Uh, this is what we wanted to do. Add k to all the elements as L comma R. So suppose we don't do it. We don't do it. Suppose. Uh, Firstly, if we just add 2 at the position 2, so what is going to happen? In difference arrays, we just add 2 to all these positions. So according to the what will be our array A? It will come out to be, we just need to take the prefix sum to calculate the array A. So Yes, sir. Yes. And yeah, I'm just defining it. Uh, and firstly, we were making from the array A, but I'm just now I'm taking a difference array, and we will make the array A from that. So yeah, yeah, yeah. So uh, now we are two at the position. So now we want to see how the our array A is changing if we take it as like that. So if we add 2 at the position 2, then its effect is taken to all over the right. So this is 2 is added to all the indexes from position 2 to all till the right. Uh, so this is how adding adding changing some value at in difference array. This is how the array changes. So uh, I took the difference array as like this. And, like yeah, you understood now. This part. If we have some difference array like this is what our array is originally will be. So a of I, if difference array is this, then a of I comes to be this. A of I is just the prefix sum of the difference array. So by by that time take that. So from this, our array comes out to be 002222 like that. So now what was our query? We want to add uh, 2 to the elements from where, where you are to, where you are saying about that. Yeah. Yeah. A0 is basically difference of 0. This is a base case, so it is taken like that. We don't take difference at that, the very first position. Okay, 0 minus 0 is 0, 0 minus 2 is 2. Difference of I is A of I minus A of I minus 1. So it is 2 minus 0. So it comes out to be 2. Okay, and you can say you can calculate difference array from A, so it will be come out that only. So 0 minus 0 is 0, 2 minus 0 is 2, and for all that 2 minus 2, 0, all are 0. So now by adding 2, we added 2 to all the in the array. We added 2 to all the positions from 2 to 7, 2 to 6, 2, 3, 4, 5, 6. So, but our original completion was to add 2 to all the elements from 2 to 5. So, but it's adding, but it is also traversing to the elements with, but it's changing all the elements to the right. So, what we'll just do is, uh, we will subtract 2 from at the sixth index. So now our array will be come out to be this this was our previous array, and at the sixth index it will come out to be 2 minus 2, that will be 0. So this is what we wanted to do. So our original operation our original query was to add k at two position to all the elements in the subarray L comma R. So we are doing that by using two things. Firstly, we want to add we need to add k at the position L, and secondly we need to subtract k at the position r plus 1. Yeah, we saw that how it is working. So if we add anything in the difference array, then the effect of it, if the effect of it will be traveled to all of the right. So if we add k to at the position L, then the effect it will be continued from L to n minus 1. But we want to L2, the effect of it will be continued to L to L minus 1. But we want it to not n minus 1, we want it to L. So after adding k, we will subtract k from the element r minus 1. So the effect will be neutralized for the elements we don't want. So this is how we are performing our query in the case of difference arrays. So by using that, we can perform our query in of one time only. In, as we are performing only two operations that take off one point time. And now if we have q queries, so it will take off q time. But previously it was taking off n into q. So we have done quite better than this, better than that. So but from this, we can't just find the value of a of I directly. For the, like you can see, for getting the array A, we need to take the difference. We need to take the prefix sum of the difference array, and that we don't have originally. If and that changes difference array changes after each query. So for calculating the array A, we will need to take an extra operation. We will need an extra operation of n, because we need to take the prefix array. So this is how we are doing our query. So got it? No, we don't need to take calculate it after each query. So our question was to calculate perform some q operations on the difference array, and later we want it. So we are just performing the q operations on it, and after that we will calculate the at the last we will calculate our array A. So this is how it will be done. Okay, so got it. Uh, so now will we move to our next topic. So as we said, the time complexity of the different update in difference operation will be O of 1. So for Q queries, it will take only O of Q time. At the end of the queries, we can take the prefix sum of the array D for the final array. So D is the prefix array. So if our array has some uh, like in this, we take our original array to be 0 uh, as all elements as 0. Now if our original array was not like that, like it had some values instead of 0. So how will we perform that? So in this, our algorithm will not change much. We'll just take these original values and we will add them in our final array. So like in this, we have calculated our array as this. Our, after some query, if we will perform the queries in our array like we did before in the case of 0 comma 0, and after that we will add add these values to our array resulting array. So the algorithm will not change much. We just need to add these elements to our array. So this is how it will be done if we don't have a zero array. So now we have some questions. So the first question is, we are given an n cross n grid representing the map of a forest. Each square is it's a grid, so it's a 2D array of size n cross n. It's a square array. So each square is either empty or contains a tree. The upper left square has coordinates 1, comma 1, and the lower right square has coordinates n, comma n. Your task is to process few queries of the form: how many trees are inside a given rectangle in the forest. So uh, uh, speaking about mathematically, so we are given a 2D array of uh, rows and columns both n, and we are given q queries, and in queries is this is how many trees are there inside a given rectangle. So how will calculate? So we need to calculate the number of trees inside a given rectangle. So this is a query like we need to calculate the sum of all the values inside a rectangle. So does anyone want to tell how we'll do it? Like suppose we are see from an example from this sample test we are given so this is our sample test, and like this is a rectangle 2 comma 2 3 comma 3. So 2 comma 2 to 3 comma 4. So this is our rectangle from here to here, and we need to calculate the all the sum of trees that lie in the this rectangle. So would anyone like to tell how we'll do it? Like this is our input only. In the input we are given two integers n and q. N is the like size of the array. So and the 2D array it was n into n grid, so we are given n for that, and q are the queries, number of queries we have. And this is the 2D array we are given in like that. Like in this dot is that it is an empty square, and asterisk might make we have a tree in that. So these are input. This is just the input format. And for each query we are given the coordinates. We are given the uh, coordinates of the upper left corner and lower right corner. So how will we calculate it? Like we are given 2 comma 2 to 3 comma 4. So it will be we need to calculate the number of trees in this subrectangle from here to here. So how will we do that? Anyone have any idea? Yeah, so it is like that. So how will uh, we just study about 2D prefix sum. So in 2D prefix sums, we had some array, we had some 2D array, and we need what was the main idea of 2D prefix arrays? So we had some 2D array, and by using 2D prefix arrays, we can calculate the sum of all elements in the rectangle. So how will we do it? We are instead of the integer array we are given some this type of array. So dot means we have don't have a tree, and hashtag means we have a tree. So we will make our array from this. So if we don't have a tree, then in that we will store here as 0, and if we have a tree then we will store the value as 1. And now as before we will just make a prefix 2D prefix array and find our do our computations as like that. So got it? Got the ideology? Now we'll code it. So it will be like that. In the question, firstly, we will like to input n and q. Now it will be now second is thing is to input this character array. Instead of character array, I'll be storing it as integer array. Uh, like I've said. So it will be in the programming. It's better to take the arrays as one index. So because it's help us to lower our computations. Otherwise, we'll need to take a special case for the element at 0 because we don't have left element at that. So it's better to take a one index array to help our computations. So now for inputting it, we'll do it like we'll take a character P and C. Now, as I said, yeah. Yeah, okay. Yeah, I'm doing that. Oh, so like that. So, in the extract map, so what was our approach? So if we are using it prefix array. So if we don't have a if we don't have a tree in the array in that square, so we will store zero in our array because we don't have a tree. It's just zero. It's like zero trees in that square. And if we have an asterisk mark, that means we have a tree. So we will store one. So this will have to be uh, we inputted character b, and if b is equal to dot, then at position of I comma j, it will be we will store 0 here, and if we have asterisk mark we will store 1 at that position. So what is in array a, what we are basically storing at a comma a of I comma j stores that how the number of trees that square has. So it basically is, if it is dot, as in our question we don't have a tree, so it stores 0, and we have a, if we have a asterisk mark, then it means that we have a tree, so it will store 1 at that position. So this is how as you are you are telling about eighth line 8. Acha, okay, okay, you don't know how to define it. So, okay. So, this is the syntax of defining vector of vector. So, this is vector of vector, and if we want to define an array of define a vector of vector, then this is the syntax. Firstly, we'll name it. What is the name? So, I named it as A. Now, after that, uh, it has two arguments. First is the size of the array, and second is the value at the ith index. So it is a vector of vector. Instead of this, firstly see how a simple vector is defined. So how we define it? Vector of int, it stores two arguments. Firstly, the size of the array, and the second is the value at the value at each index. So now, like the same as before in vector of vector also. The first argument is the size of the array, which is n plus 1. I am taking it, and the second is the value at the ith index. So if we have a 1D array, we just store it as 0. But now we have a vector of vector. So uh, at each index I, we will have a complete vector instead of an single element. So this is how we define the syntax for that. We need to give a complete vector at that position. Yeah, n plus 1 zeros. So it will be like, if we have n equal to 2, then it will be showing 0 comma 0. Uh, it will be from 0 to if we have n equal to 2, it will be showing like this. So uh, it will be from 0 to 2 I comma j, and all three zeros here. So this is how we find a vector of vector. So now after that, we have we are taking the input in this. So firstly, we will take the character input. Now, instead of storing our character array, we are doing it like in storing it in integer array. So if we don't have a of I comma j, it basically stores the number of trees at I comma j. F I comma j stores number of trees in the square I comma j. Yeah, I am just yeah, just I said before, I am just taking a for one index vector. So when we are write up programs, it's better to take one index vector, because otherwise for we need to take some different type of computation for zeroth for the element at zeroth index, because we don't have a left element for that. So this is just a simple way in which we lower our computations to save our programming time. Yeah, we are just adding one element. This even doesn't affect any our memory anything. Okay, so this is how we are showing our array A. Now we want to take make a difference array. Sorry, 2D prefix array. So for that we will make another array A. We will make another array. I will make it prefix. So it will be of the same size as A, n plus one comma. The initial value I will store. It will be stored as 0. So now for all the elements. So now remember what we were doing in our 2D prefix array. So this is how we are storing the value at I comma j index. So it will be p of I minus 1 comma j plus the element at I comma j minus 1 minus I minus 1 comma j minus 1 plus the element at I comma j. So I will just write it. Prefix of I of j, it will be prefix of I minus 1 comma j plus prefix of I of j minus 1 minus prefix of I minus 1 of j minus 1 plus a of I of j. So this is how we make our prefix array. So now what we have done is our prefix array stores the all the elements, the sum of prefix in the sum of the squares, rectangles in our array. So now our original question was we need to find the number of trees in the subrectangle. So we will first input that. It will be we have our q queries. So we will make a loop for all the queries. Now we will input our subrectangle, coordinates of the subrectangle. So this is our query, how our query is given. So we are given x1, x1, y1, which are the so we are given a rectangle, and for that we are given the upper left corner coordinates and lower right corner coordinates. So from this we can make our rectangle. So this is how we are doing. So we'll just input the coordinates. So as we did to calculate the sum of the subrectangle, what we'll do is let's denote answer as the number of trees. So what will it be? It will be prefix of, like we can see we did it before. If we want to calculate the sum of subarray in this in the 2D prefix sum, this is how it is done. This is the equation. So we will just write that. So it will be prefix of x2 comma y2 minus prefix of x2 comma y1 minus 1 prefix of uh, plus prefix of x1 minus 1 comma y1 minus 1. So there is nothing new in that. I am just applying prefix sum to solve the problem. Now as our question we will just output that. So this is our code for the problem that we saw. So what from the start, firstly from the starting we'll see it. Firstly we need to take the, we are just taking the input, and now in our input was given in a character array format. So instead of that I took an integer array to store it. So what I'm storing in the array is like a of I a of I comma j. I'm storing the number of trees that square has. So for that we are given only two options, like it doesn't have any tree or it has one tree. So I'm storing it like that, and after just some application of prefix array, it is done. So understood it? Where? Line number? Yeah. Yeah, this is an array. So this is simply an array, not a function. So this is how it prefix of I comma j, like how it simply is like that. A of I comma j. It is the value that is stored at I comma j index. So it is just like that. The value at position x2 comma y2. Okay. Yeah. Actually, no. The time complexity of the program is not the same. So, firstly, we will firstly see what is the time complexity for this. So, if we not in this part is in this part we are just inputting data, so we will not count it. So, what is the time complexity for this part? We have two natural loops of size n. It is of n square, yeah, like of n square. And for this part, what is it? Order of q. So our time complexity is coming to be order of n into n plus q. So this is now suppose if we don't use prefix arrays, so what would be our time complexity? So so firstly tell what will be the time complexity of a single operation if we don't use 2D prefix arrays. Uh, we are given so what is our query? We are given a subrectangle and we want to calculate the number of trees in that. So how will we calculate that if we don't use prefix sums? You will need to iterate over the you will need to iterate over the whole rectangle. So and that will be of n into n. So the worst case, it can be the complete array. So it will be n into n. And if you want to calculate it for q queries, then it will be n into q, n squared times q. So you can see the difference. Yeah, okay. Now for our second question. So Shefflin can be presented. After says Shefflin is a grid of n cross m. The rows of the grid are numbered from 1 to n, and the columns of the grid are numbered from 1 to m. The square in row x and the column in it can be uniquely defined as square x comma y. Each grid square has cost either 0 comma 1. Now chef is going on a vacation for the q days. On the 8th day, chef would he goes from ai comma bi to ci comma di, and now uh, it is guaranteed that uh, these are constraints, and due to restrictions to movement in Sheffield, it is only possible to travel downwards and right. So he has only two directions to move, downwards and right. And in other words, mathematically, what one can say is from x comma y, chef can move from x comma y plus 1 to x plus 1 comma y. And now we are given the cost of the trip. The cost of the trip is the product of the cost of the squares that the chef passes. So now our task is to find the minimum cost that chef need to pay. So what is our basically what is our question? If we are given an 2D array, n cross m. So firstly take as input. So we are given n in m and 2D and a 2D array. So basically what is our question? We are given a 2D array. These are 2D array, and at each position it stores either 0 or either 1, which is the cost of passing that cell. So after that, we need we are given two indexes like a comma b and c comma d, and now we need to find the minimum cost to reach from, like, we take from a comma b to c comma d. So it is making a subrectangle again. So suppose we have to we these are we take as 1 comma 0 and 3 comma 4 3 comma 3. So these are subrectangle. So now if we want to reach from 1 comma 0 to 3 comma 3, we need to find the minimum cost. So and the cost is the product of all the cells you pass through. So a basic approach can be, uh, firstly, we are just taking the product of all the elements, and initially the all the elements are 0 or 1. So from this we can say that final cost can be either 0 or 1, because that's the product of the elements only. The We will have the final cost as 1 if we traverse through the cells that has the cost 1 only. So by this, our final cost will come out to be 1. And suppose if we traverse through a cell with cost as 0, then our uh, in our product there will be a term as 0. So if we multiply something as 0, then it will be 0 only. So if we traverse some cell with cost 0, then our cost will be final cost will come out to be 0. Otherwise it will be 1. So these are computations. So now, uh, 0 and 1, we need to minimize the cost. So what are questions comes down to be, we need to see if we have some path uh, going from the position with cost as 0 from a comma a to c comma d. In that case our cost will be 0, otherwise it will be 1. So any idea how will we do that? uh, Input is basically n and m. This is size of the 2D array, and after that we are given the array, and so n lines, we are given n lines and each representing m elements, and after that these are the queries only. So these are the queries. So don't look at firstly don't look at the queries. uh, we just see the array for once. So we will just find how we'll calculate our answer for one query, a single query. So our query says is to we are given 2 points a comma b and c comma d, and we reach to a comma a to c comma d by using right and down operations. So we can move only in these cells, in these matrix only. So now our cost, we need to minimize the cost. So we need to tell if there is a path, if we there is a path containing element 0, we can traverse with. In that case our cost will be 0, otherwise it will be 1. So to minimize that cost, it will should be 0. So tell tell how will we do it? Okay, so if no one have any idea, so how will we do it? So if we want to reach from a comma b to c comma d, uh, then it yeah, but for that the time complexity will reach exponential. For every element you need to check which path to move. It's basically like you are searching for all the paths, and that is there are exponential paths. There will be like for the each for each traversal unit we have two paths, so it will be 2 into 2 into 2, so it will reach exponential. Okay, so think like that. We have this submatrix, we reach from 1 comma 0 to 3 comma 3. So we have this submatrix. Now first thing, if we don't have any zero in any zero, all are if we have all ones in this in this submatrix, then how will our question respond? Then we don't have any option for zero. uh, uh, Stop like that. Suppose we have like this, and we need to reach from 0 comma 0 to 2 comma 2. Now our cost will be 100%, our cost will be 1 because we don't have any 0 in our matrix. So there is no case when the final cost can be 0 because all are ones. So no matter which path we take, our final cost will come out to be 1 because we have all ones. So you got that? Uh, yeah. So now suppose if we have some element having a single 0. So how our thinking changes. So if we have a 0 in this matrix and again we are moving from 0 comma 0 to 2 comma 2, then how will we progress it? If we have a 0 in the submatrix, so always we can find a path that will traverse that will move from this uh, that will go from this uh, then there will always exist a path from 0 comma 0 to 2 comma 2 traversing from this. You can always see that. So like from this we can do it from first from go here to here and then now from here to upside down. So if we have a 0 in this submetric in this matrix, then there will always a path uh, by which we can move from the lower left uh, upper left corner from to the lower right corner. uh, if you don't get it, think it like that. Mm, if we have it like this, huh, now suppose we define it is 0. So if we define a path, how will we traverse? Now our task is to define a path such that we can reach from the lower left upper left corner to the lower right corner traversing this 0. So what we will do is, firstly I will traverse from uh, the column containing 0. So I will move from here to here, then I can move down till 0. So I have got a path uh, that passes through 0, and from this path I can reach till lower right corner. So we have a path in which that if we have a 0 in our in our matrix, then we can find a path that traverses through 0 and uh, moves from lower left upper left corner to lower right corner. So now our problem reduces to check, but check if we have a 0 in our submatrix or not. So you got that right? Okay, if not I will explain again. So uh now this is we have a matrix like this and we have a 0 in this. We have some element as 0. Then our task we have to check if there is some we can make some path traversing through 0 this 0 to reach from lower left from this element to this element. So you can think that we can always make a path like that because uh, what we can do is think like logically. Uh, we'll just make a path like we'll first move from to the upper top element of this column, uh, and that we will move down this corner move through this column move down through this column, and from this from the last element of this column we'll move to the rightmost element. So we have a path moving from it is like we are moving from here to here, then moving down. So our requirement is fulfilled through that. So we are moving from lower left corner, upper left corner to lower right corner and traversing through 0. So By this, we can always make a path. If we have a 0 in our matrix, then we can always make a path to that passes through it. So in this case, our cost will come out to be 0. So whenever we have a 0 in a matrix, our cost, we can find a path such that our cost is 0, and our cost will be 1 only. Cost is 1 only if all are 1. So our task is to check if we have some 0 in our matrix or not. If we have a if we have sing if we have at least one 0 in our matrix, then our cost will be 0. Otherwise, it will be 1. Okay, you get it right? Okay. So how do we check it? Now, if now our task is to now we will do it like you have any idea how we will do it? We have to check if for a now our task is like we are given a matrix, and in a query we have to see if for that we are given a rectangle in our query, and we have to see if we have any zero in that matrix or not, sub matrix or not. Okay, so this also we can do using prefix sums. So in our last time, in the last question, we are storing a I comma j stores the number of trees in the square I comma j. Now in this we will at I comma j we will store if it has a 0 or not. If we have a 0 at that position, then a of I comma will a of I comma j will store 1. So what is a of I comma j stores is storing a of I comma j stores the number of zeros at I comma j. So if we have a 0 at I comma j, then a of I comma j, the value of I comma j will be 1, otherwise 0. So now if we have a submatrix and we need to check if there is a 0 or not, we can just uh, see if like iterate over the basic what was firstly think of the basic thinking how we'll do it. We can just iterate of the matrix and see if there exists or a 0 or not. So it will take of n square maximum, but we need to reduce our time complexity. So we will do it like using prefix arrays. So it's like we will count the number of zeros in this submetric. Uh, as in the previous question, we will we write a program to count the number of trees in the submetrics. We will count the uh, number of zeros in the submetrics. And now, if we have more than one zeros in the submetrics, greater than if we have uh, one or more than one zeros in the submetrics, then our cost will be 0. Otherwise, the cost will be 1. Okay, you got it right? Jyotin mein? Okay, so we can write the program for this. So delete it. So what are the constraints of our program? Firstly, we have a n cross m matrix, then q queries. So it will be like firstly we input the size n cross m and we will store it. So I am just defining a 2D array. Now for taking the data, I will require two nested loops. So one with j and one with n. Huh. So now for int b, scene b. Now what a of I comma j stores number of zeros at I comma j. So now if b is equal to 0, then it means that we have a 0 at I comma j. So we'll store it as a of I comma j is equal to 1. Otherwise it will be 0. So after that we will make this prefix sum for this. So it will also be a 2D vector prefix sum, and just as before we did calculating the prefix sum. Uh, the program for that will not be changed. It will be just like that before, uh, but only the constraints will change. So it will be prefix of I comma j will be prefix of I of j minus 1 plus prefix of I minus 1 of j minus prefix of I minus 1 of j minus 1 plus a of I of j. What? Yeah, yeah, okay. That, yeah, like, yeah, you can see we are defining a 2D prefix array. So in this, we are taking all the elements as 0 initially. Yeah. Yeah, okay. Yeah. So, okay, that is kind of a base case. So, suppose we have, okay, think of like that, see it like that. Like if we have this array, 1, yeah. If we want to calculate prefix of 0, 0, so how it will be? What will it will be? Pure prefix of 0. No, it just stores the value at 0. So if we don't have any index, so it will be like we are uh, we don't have an index, like, so it will just store 0 at that. Yeah, 1, 1. Yeah, yeah, we don't have any value. So that's kind of a base case. But what is doing in base case? If we don't have any value, we'll just store at 0. Uh, so yeah, kind of. So you can also do that, like uh, making cases. If it is 0, then prefix of I comma j is basically a of I comma j. So what is prefix of I comma j basically? A of 0 of 0. So you can also make that cases like, but if you see from here also, all this will be 0 because we don't have any positions for that. So it is also a of I comma j. So that was I was saving before. So if you make one index array, so your computations are like reduced. So like we did it in a single step. Otherwise, uh, we need to take write four cases, like if j is 1, I is 1, or j is greater than 1 and I is greater than 1. But uh, if we don't have any positions, we are just storing 0. So this is to lower our computations only. And okay, so so now uh, in this we make our prefix array. So after that we need to input it. We need to process our query. So it would be like that. If our will input our submatrix, it the coordinates of the opposite coordinates, the coordinates of the upper left corner and lower right corner. So now we need to count the number of zeros. Now we have stored the number of zeros at I comma j. So now we will need to count the number of zeros in this submatrix. So number of zeros. So it will be like as before. I'm not then changing anything, just the same code that I had before. Prefix of x1 minus 1 of y2 minus prefix of x2 of y1 minus 1 plus prefix of. So this gives the number of zeros we have in this submatrix. So now is if we have, if we have 1 0 or greater than 1 zeros, then our cost will be basically uh, int cost. If we have one or more zeros, then our cost will be basically one, because as we discussed before, we can have a path passing through 0. So this will make our cost 0. And if we do not have any 0, then our cost will become 1. Uh, Now just we need to output it. So these are as our code for the program. So firstly, we are just taking the input and storing it like the number of zeros in we have. So this kind of the main thing you need to think, you need to notice while solving the problem. You need to think that what we are storing at position a of I comma j. So in this, like, I am storing the number of zeros. In the previous, we were storing the number of trees at I comma j. So you need to double check it what you are storing at the position. And after that, I'm just inputting and yeah, yeah, yeah. Okay, okay. I will just make a diagram. I will just make a diagram. So suppose we have this array. Uh, firstly, we'll have I'm taking as n equal to 2 and m equal to 2. So as we are taking as at one index, so but we will also have some values at 0 index only also. So it will be like if we have we are given an array as 2 comma 3 and 4 and 5. So how it will be stored in our in this. So it will be stored as 0 zeros. When we have 0 indexes, then it will be stored when the index is 0, the value at that index will be stored as 0. So it will be stored it like this. It will be stored like this. So it will be our original array. And yeah, yeah, yeah. So so this is our array is getting stored. So now, uh, this was how we are calculating it, the prefix sum. So now if we calculate what, yeah, uh, we, we will first find the prefix. It's kind of pre-computation. We don't require any query. We are calculating the prefix sum for all the for all the elements in the array. So this was our array. If we find the prefix array from this, so firstly for the elements we will iterate it like so. How we iterating it? Firstly, we are iterating at I and then they and then j. So firstly, if we don't have firstly at the indexes where at the elements at the indexes 0, the value stored will be 0 as we have stored it initially. So initially all is stored at 0. So like this. So initially all are 0. So now we are traversing firstly traversing I from 1 to n and then j from 1 to n. So how we are traversing? Firstly, we have two loops. In the first loop, we are traversing from n equal from we are traversing from I equal to 1 to 2. And now in the second loop, we are traversing from j equal to 1 to 2. So the first loop is traversing our columns. Like these are sorry rows. So these are first row, zeroth row, first row, and second row. And in the for the second loop, we are traversing columns. So this is the zeroth column, first column, second column. So now we'll calculate the prefix sum like that. So for I equal to 1, prefix sum is like prefix of now. Firstly, for I equal to 1, the first is 0. So what will be the prefix of I 1 comma 1? So tell it from this formula. Yeah. Okay. So prefix of 1 comma 1 will be 2. So we'll just update it. So now again after 1 comma 1, what will we have? Prefix of 1 comma 2. So what will be the value? So it will be prefix of I of j minus 1. So it will be prefix of 1 comma 1. So yeah, that will come out to 5. So it will be 2 plus 0 plus plus 0 plus 3. So 5. So according to that, all the values will be it will be 6 and it will be 14. So this is how our prefix array is getting calculated from this using this uh, using this computation. Okay, got it. uh, okay, so this was our question. Yeah, so what were formula 14. So it was prefix of 2 comma 2. So by the formula what will be prefix of I comma j minus 1. So prefix of 2 comma 1. So 2 comma 1 is 6, right? After that, prefix of I minus 1 comma j, which is 5, minus prefix of I minus 1 comma j minus 1, minus 2 plus a of I comma j, that is 5. So it comes out to be 40. Okay. Okay. Now back to our question. So we are calculating the number of zeros in our sum matrix. So I'm showing firstly we will just store it, and using the prefix sum we'll store we will traverse a prefix sum on this. to store the number of zeros. And like we did in a previous question, we'll just find the number of zeros with the help of prefix sum in the matrix. And now, if we have if the number of we have one or more zeros in the sub matrix, then our cost becomes zero. Otherwise, it will be one. Okay? No, actually, this is not. We are not applying to a prefix sum two times. This is the pre-computation we are doing on the array. This is the pre-computation. This is the pre-computation part we are doing. Okay. This in this we are storing. We are storing storing the prefix sum from. We are storing the values in the prefix array. From the array A. No, they are by in the stating they are zero, but we have to store some values now, like we did here. Like we have to store it like this, and from this is the part which is doing that. After that only we can make any computations. Now, yeah. This is not the for loop. This is the for loop is for the queries. The prefix arrays part is only this. In this, we are only performing a query. For query, we just need to. This is the only the query part. We are finding the number of. No, it will not be always greater than one. It, it can be zero. Like we are getting the prefix of the submatrix. Like suppose of the all the elements are zero, then it can be zero also. Yeah, or maybe negative if we have negative values. So this was our part in which we are doing computations of we are computing prefix array, and in this we are just applying a single operation to find the number of sum of elements in the prefix sum. So we are not applying it two times. This is just two different parts. Okay, so suppose we are given to uh, take this as array only. So this is our array, and our query is 2 comma 2 and 5 comma 3. So how it is going? So firstly it is a one index array, so 2 comma 2 is this position, from this position uh, to this position. So this is our sub array 1 1 1 1 1 1 1 1. So what is it? 1 1 1 1 1 1 1 1 1 1 1. So this is our sub array. Okay, and now in which that are not required. We are looking for this submatrix. It will make the it will make the prefix array for all the elements, but for our query, we just require that. So we are will compute for only this. Like you are saying about this part now. So this will be computed for the whole array in the starting. Yeah. What kind of? I didn't got what I was asking. Yeah. No, we will not move to 2.4. Like, what is the submatrix of the of what is the rectangle made by these two array these 2 points? Think of the subrectangle with these endpoints 2 comma 2 and 5 comma 3. What is the subrectangle made by this? Yeah. Yeah. Yep. Uh, yeah. In the question we are given that the chef can only move from right, can only move to right or down. Like if he goes from, like suppose if he goes from out of the matrix, like if he move to reach this position, then he can never move, reach to this position, because he will have to take a left step that is not allowed. So that's why we are only taking that sub matrix. Okay. uh, so this is how we got it. So like we'll firstly compute the whole matrix, and we just need to find the query for this matrix. So this will give us the number of zeros in this. So this is how it will be done. So now moving to our next question. So it is range product updates in of 1 where k is less than equal to 1. So up till now we were using prefix sum to find the sum, to make the sum queries. Now suppose if we have a 1D array like this, and we need to 1D array of size n, and we need to find the product of the elements in some range. How will we do that? We are given q queries, and each query says find the product in range l comma r. So how will we do that? uh, just say what you got from the prefix array. Do you get any click from the prefix array, prefix sum array? How will we, uh, like as we did in the prefix sum array, how can we apply the same here? Okay, so think of it like this. For doing it, we'll do the same thing as we did for the prefix sum. We'll do same as like prefix product. So in the prefix sum array, what prefix of 5 are storing? Prefix of 5 are storing some of the elements from a of 0 to a of 5, and in this product we'll just store the product of elements from a of 0 to a of 5. And now if we want to calculate a of product of elements from a of l to r, then it will basically be prefix of R. Prefix of R will contain the product of all the elements from 0 to R, and we will just divide prefix of L minus 1. So we will get the product of all the elements from L to R. So you got it? Yeah, this will have flow, but we are said that will not overflow. We are given the constraints, like test cases are made like that. So it's just a kind of thing we can think of, like the different types we can apply the prefix sum. This technique. This is so we have studied some method like prefix sum. It's a method we have studied, but we can also apply it in different types. Not we can instead of using prefix sum, we can also apply in different type of questions with different types of uh, applications. So this is a kind of one computing different product. Yeah, you were saying right. It will overflow of absolutely. Yeah. So, okay, it's not time to do the next questions. I will just move to the next slide. I will share the links of the all the problems. If you have any doubt, you can ask me personally. So now the circular arrays. These are next topic, circular arrays. So what we have a not what is our normal arrays like? Suppose this is a random array. So Firstly we have a of 0 s2, a of 1 s3, a of 2. Like how will we traverse it? Firstly we will reach from 2, start at 2, then after that we will start at 2, and after that we'll move to 3, then 4, then 56, then 35, and then 6. And that we don't have any element to the right of 6, then we'll break it. Our traversal will stop here. So this is how we traverse a normal array. But in the circular array is kind of a different array. It's kind this type of array only. But in this we are like after the last element we reach to the first element only. So if we take it like the circular array, so it will how it will be like. So after the sixth element, after the last element of the array, we will reach to the starting of the array. So if we take it as the if this was our circular, if instead of the normal array it was a circular array, then how it will be traversed? So firstly from 2 we'll reach to 3, then 4, then 56, then 35, then 6, then after 6 we'll again reach to 2, and again that, then again 2. So it can be like we have, and we are moving from 2 to 3, then 4, then 56, then 35, then 6, and again we have an edge to move from edge from 6 to 2. So from here to here we have an edge. So it's like a circular array. So if we traverse it, it will never going to end because there is a loop in it. uh, if we want to completely traverse it, it will take infinite time. So this is what a circular array is. Now if we want now what we are actually in the traversing, how we are actually traversing it. So firstly when we traverse it, reaches to it reaches to the element at index 0, then index 1, then index 2, then index 3, then index 4, then fifth index. So and after fifth index, so it reaches to index 0, then again 1, then 2, then 3, 4, 5, and again 0. So what does it mean? Like if we are traversing the array x times, if we are traversing the array x times, then it reaches to the index. It reaches to the element at index x mod n. So you can see uh, like fifth, here n is equal to 6, and if we traverse the array 6 times, it reaches to 6 mod 6, that is 0. So this is how we traverse our circular array. So, and in a way, rotating a circular array would mean that the array does not change at all. That we can see, uh, that we can know. Like we have array this type. It's a circular array. We have circular array. If we just rotate it, then the array will remain as same. Only the indexes will change. Indexes of the elements will change. The element array will not change at all. So the main thing in that is, uh, if we traverse the array x times, then the index it will be x mod n only. So this is the thing you need to note. If we traverse the array x times, like from here x we traverse to x times, then it will reach to the element at index x mod n. Remember that this is a very important thing. So now uh, if we have some kind of problems on these circular arrays, then to solve them what we can basically do is, uh, we can attach another, we can double the array. So like we have this array, like we have this array 2, 3, 4, 56, 35, 6. So if we have some problem on this, what we will do is, we'll just double this array. So So array will attach another array after this. So it will be 56 and 35 and 6. So by doing this, this will help us in our computations, because like if we have a problem, then for every element, we must need to travel to all the elements on the right. Like say if we have a problem on find the next greater element. So if we have to find the next greater element, then we need to traverse all the elements to the right. So for 2 we can traverse it because all the elements are at the right only. But for the 3, these elements are at the right, but after that we comes to the element 2. For that we will have to take mode or something, some other kind of computation. That is a bit harder because taking a mode every time makes a code nasty, and that also doesn't most of the times. So for the kind of technique, we for the solving circular arrays, we just double the array, and this helps us in our computations very much. Now uh, we'll just solve one two problems on it. So this is a problem. Monica has just learned a new card trick and can't wait to present it to you. He shows you the entire deck of n cards. You see that the values of cards from the topmost to the bottommost are integers a1 to an, and all values are different. Then he asks you to shuffle the deck m times. When the jth shuffle, you should take bj topmost cards and move them under the remaining n minus j cards without changing the order. And then, using some magic, Mulkan tells you the topmost card of the deck. However, you are not really buying that magic. You tell him, you know the topmost card yourself. You can surprise Mulka, tell him the topmost card before he shows it. So what is it like that? Firstly, you have an array from A1 to AN. Now, uh, now, Munakab will shuffle the array j times. Then in the j shape, you take the some number of cards from the top. Like you know how many cards you are taking. Like BJ cards. You are taking BJ cards from the top and put it uh, at the bottom. So what you are doing it like some suppose if you are starting array 3 1 2 1 4 3 5, and now you are performing some operations. What will you do it? You will take some top cards and put them in the bottom. So like in the first operation, you take 2 cards and put them at the bottom. So how what you are actually doing is you are taking these two elements 2 comma 1 and sending to the last. So after the first operations, the array would be uh, 4 3 5 2 and 1. So 2 and 1 are moved to the last of the array, reach to the last. So this is how what we are doing. Now again, if we have a query, now if we shift 3 cards to the last, so how we do it? Again 4 3 5 2 and 1, 2 1 4 3 5. So this is how our array changes after we shuffle it, after we shuffle every time. So after that, what we are asked you to do is, and then using some uh, you need to tell the topmost card before he shows. So what will be the topmost card? So basically, think of it as a circular array. After the element fifth, you are reaching the second element. So firstly, the index of these are like 0 1 2 3 4. These are the index of all these. Now firstly, the card with index 0 will be at the top. Yeah, that's not this simply uh, as simply the card with elements in index 0 will be at the top initially. Now uh, think now take if we move the first two cards to the last. So what will happen is 2 and 1 will move to the last. So 2 and 1 will move from here to here, and our topmost card will become thus with the second index. So what is actually happening is uh, 2 and 1, we are taking 2 and 1 out of here. So the first two indexes are we are हम इन्हें बाहर निकाल रहे हैं. 2 and 1 को हम we are making out 2 and 1 को हम हटा रहे हैं टॉप से. So if we have removed the first two cards from the top, then which will be our top card now? So it will be 0 plus 2. So the second index card will be at the top. Now it is that if we again remove the four cards from the top and put it at the last, so what will be our new element at the top, new card at the top is. So the lastly we have second element card at the top, so we'll add 4, so we'll have a sixth index card at the top. So we do not have 600, it will be 6 mod n, because these are circular array. If we traverse it x times, so the index would be x mod n. Yeah, yeah, that I'm saying. So we thought I'm saying to take it as a circular array. So in this n equal to 5, n is equal to 5, and for the circular array, what you do is if you traverse the array x times, then the index of the what is the index of that element that you are at? It is basically x mod n. So now I traverse the array 6 times, so it would be 6 mod n. So it is 6 mod 5, 6 mod 5, which is 1. So got it? Okay, so from the starting. So uh, suppose we take our element array as this. Okay, so this is okay. So now, firstly, according to our question, firstly which is the card at the top? The card with index 0. Okay, yeah, that is obvious. So now think, if we remove the first two cards from here, then what will be the index of the card that would be at the top? Yeah, it will be 0 plus 2. The card which was at the top at the last, and moving two cards, it will be 0 plus 2. Okay, now that two cards now will become now will reach at the last, so it will be according to our query we will move those two at the last. So now again, if we move again four cards from here and put them at last, then what will be the index of the card at the top? Yeah, okay. And it's the we're taking this circular array, so it will be 6 mod 5. It will be 0 plus 2 plus 5 mod 5. Okay. Like we are iterating it like a circular array. So think of it like how we are doing it. Uh, what was our original array? 3 6 what is it? 7 3 6 7 3 6. Now what we are doing? We are removing this 7 and 3. So think of it like differently. We don't remove these cards. We take it as circular array. Like from 10 we reach 7. So if we remove this 7 and 3 from here and put it at the last, so what we are basically doing is from here, from 10 we are reaching to 7, right? So this was the case of the circular array. Yeah. Okay. So that's like we are doing it. So these are so uh, actually, what is our query? We are removing the first two cards. So what can we think of? Think of a different way. Instead of removing these cards, we take it as a circular array. So we reach from 10 to 7. After 10, we reach to 7. And instead of removing the cards, we traverse the array. So now this was 0. This was the index of the card which is at the top. Now if we remove the two cards from here and put it the last, so what are we basically doing is we are traversing two cards. We're traversing the array by index, two index, two times. Now, yeah. Now again, if we want to remove four cards, we'll traverse it four times. So it will be like from 10, 10 like two times. It will be come to 7 and then again. So it will be like this. So now again, yeah. Now if we are traversing the array x times, then what would be the index we will reach at last? If we traverse this array x times, then what would be the index that we reach? Yeah, that we discussed. So it will be like this. So it will be x mod n. So just like that. What I did before, just the same thing. Okay. So now we are given the array, and we have to perform an m operations. So we'll write the code for this. So it will like firstly we will input the array. I'm okay. It will be confusion. So for int uh, I'm inputting the array here of I. So after inputting the array, what you have to do is uh, we have to it is getting shuffled m times. So and we are given the number of cards it gets shuffled at times. So we need to input this also. So m cname and the array b containing the number of cards it gets shuffled the ith time. So it will be b of m. So for int I equal to 0, I less than m I plus plus c b of I. So okay. So now as we understood before, uh, if we are we are taking first x cards from the top, not x. Take it as if we are taking k cards from the top and putting it before. So it means that we are traversing the array k times. And now we are doing this operation m times. So in the first operation, we are taking b1 cards, b0 cards, and putting it top, then b1, b2, b3. So what does that mean? In the first operation, we are taking b0 cards, we are iterating the array b0 times, and in the second operation, we are iterating the array b1 times, and then b2, b3, b3, b4, and then bn minus 1. So in total, how many times we are traversing the arrays? The sum of all these. Yeah. 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 Okay. So in total, we are traversing the array this many number of times. The sum of all this, the sum of the array b. So it will be taking as sum equal to 0. So it will be, we just need to take the sum of the array. So it will be sum equal to sum plus b of I. So this is the number of times we are traversing the array. Now, if we traverse the array as before, if we traverse the array x times, what is the index of the card we reach at is x mod n. So basically, our answer will be index will be sum. Sum defines the number of times we iterate the array. So sum mod n, the size of the array. So remember it. N is the size of the array. We are doing we are doing the operation. So we need to output the size index. So this is our code. So we can see is I will run it again. So one thing in this the array we are given is one index. So but we are finding the index. What we are finding a result at index 0. So we need to add one in this. Because we are finding our index as zero indexing. We are giving doing it like zero indexing. So our index are like 0, 1, 2, 2, and minus 1. But the question is asking to print the result in one index. So 1 to n. So we'll just need to add one to change the range, change our range. Yeah, okay, sorry. We have cases. So uh, firstly we have n cases, t cases. So we need to define t cases, and for each case we are doing that. So it is an answer. Okay. I got wrong. 3 to 1. CP minus minus 3 1 2. A of n senior 5. So oh sorry. Sorry. We didn't need to output the index of the card. We need to output the card which is at the top. So we found the index. So if we have index of the card, then what will the card that will be at the top? It is just index of y. A of index, sorry. So 2333. So this is what was desired. So this is how we do the problems using the suffix array, not the suffix array. We do the problems including the circular arrays. Which is this is the most important thing. We need to always remember that if we iterate the array x times, then the index we reach after that is x mod n, and that defines the result. Okay, do you get it? Okay, so uh, it's not time to do remaining problems. So I will share the remaining all the problems with you in the group. And thank you for the class. And we'll close it now. Okay, thank you all.